Okay guys, we're going to do a little part 2, and we're going to look at some quadratic equations now that are missing the middle term. Okay, so they'll have an x squared term, and they may or may not have the constant. They would still fall under this category, and we can actually solve them. Sometimes they can be solved by factoring, but we're not really going to get into that. But they can all be solved using what's called the square root method. Okay, and this just means that we can isolate the variable. The reason we can do that, guys, is because there's only one term that has a variable. We couldn't do that with these that we saw previously, okay, like this one for example, because although we're using the same variable in this, well, let's look over here. In this equation, we can't actually isolate x, and the reason is because we would never be able to combine x squared with x. Those would be unlike terms. Okay, but if there's just one term that has an x squared, then we can actually isolate that term, and we can solve that for x. And that's what we're going to look at. Before we do this, though, I want to do just kind of a brief review on working with square roots or simplifying square roots. So first of all, what is a square root? Okay, so what is the square root of a? Okay, well, the square root of a or whatever is just a number. It's just going to be a number, we could call it b, such that if you square it, it is equal to a, or it gives you a. Okay, so when we talk about the square root of 25, it's 5, because 5 squared is 25. So taking the square root of a number is the opposite of squaring it. Those are inverse operators.
The entire class, she just sat by the side.
And then I'll give you another example. What would the square root of 49 be? Well, that would be 7. Okay? All right. Okay, so what about, oh, let me give you another example real quick. What if we had like the square root of 40? How would we do that one? Because that's not just an integer. It's not 5, it's not 6, it's not 7. Okay, because if you square those numbers, you're never going to get 40. So how do we treat radicals like this, or square roots like this? How do we simplify them? Well, we try to factor the 40. Okay, we try to factor it such that one of those factors we can take the square root of. And if I were to factor 40, 4 times 10, okay, then I can take the square root of 4. And the square root of 4 is 2, and then I can't really do anything with the square root of 10, so it stays in there. So this is how you simplify a radical like this, okay, when 40 is not what we call a perfect square. You have to factor it such that one of those factors is a perfect square, and you can take the square root of it. Okay. And then lastly, how do we deal with, what if I had something like this, the square root of negative 25? Well, we know the square root of 25 is 5, so you might think the answer to this would be negative 5, but it's not. Because if you square negative 5, remember, anytime you square a negative, you get a positive. Okay? So the square root of negative 25 is not negative 5, and it's not 5 either. In fact, guys, we say that it's not a real number. More specifically, we say that it is a number, but we're going to call it an imaginary number. Okay? And the way you do this, or the way we do this, is we have to actually define what it means to be an imaginary number, or an imaginary root. And we say that the square root of negative 1 is equal to I. Okay? So when you have something like the square root of negative 25, you still factor it, but you factor it such that the 25 is in one of the square roots, and that factor -1 is in the other one. Because 25 times -1 is -25. And when you factor it this way, you can take the square root of 25, it's just the nice integer 5, and then you use this definition, the fact that we're going to define the square root of -1 to be I. Okay? And so this becomes 5I. This is what in math we call a purely imaginary number. Now when I say imaginary, I don't want you to think that it's a number that I just made up, or that is imaginary in the everyday sense of the word. Okay? It is a number. It's just part of a larger number set. Okay? We mainly deal with the real numbers, the numbers that are on the x-axis, but there are other numbers that involve I. Okay? And that larger set of numbers that not only includes the real numbers, but also numbers with I in them, that larger set is called the set of complex numbers. Just so you know. Okay. All right, so how do we deal with, let's look at these two examples right here. How would we deal with the square root of -5? Well, we factor it. We factor it, the square root of 5 times the square root of -1. We know by definition the square root of -1 is I. And then you'll try to take the square root of 5, but you can't. So this remains the square root of 5 times I. Okay? And then lastly, if you had the square root of -24, how would we deal with that? Well, we know we're going to get an I out of it because it's got a negative. Okay? And so 24, though, is not a perfect square. So we factor it as well. Okay? But I'm going to need 3 factors. One of my factors is -1, and then I need 2 factors of 24 such that I can take the square root of one of those factors. So I can do 4 and 6. And the factor, the perfect square factor, you always want to put at the beginning, because this will turn into just an integer. So what is the square root of 4? Well, it's 2. You can't take the square root of 6, so it stays the same, and then we said the square root of -1 is I, or that imaginary root. Okay. Because we need to know this, not just for these two examples, but also down here when we start looking at solving quadratic equations using the quadratic formula. Okay. Alright, so let's look at example 3. So here we have this quadratic equation. And you can see that it's missing the middle x term, so we can solve it for x. The way we do that is we isolate the term that has x squared in it. So I start by adding 6 to both sides of this equation. So I get 2x squared is equal to 6. And I continue trying to isolate the x squared. Okay, so it's multiplied by 2. So I will divide both sides by 2. And that'll give me x squared is equal to 3. And then here is where the square root part comes in. Remember how I said the square root was the opposite of squaring something? Those are inverse operators. So if I want to convert an x squared into just an x, I do it by taking the square root of both sides. The square root of x squared is x. Because what do you have to square to get x squared? Well, you have to square x. Okay? And then over here you have the square root of 3, which we're not going to be able to do anything with. But also, guys, not only do you have the positive root, you also get the negative root. And the reason that you get both a positive and a negative is because of the square right here. What does squaring something do to a number? If it's a negative, it turns it positive. And if it's already positive, it stays positive. That's why both a positive and a negative square root of 3 will work to solve this equation. Okay. A rule of thumb is that whenever you are solving an equation and you have to take the square root of both sides, you're always going to have a positive and a negative root. Okay, so don't forget that. So those are the two solutions for x. We could write x is equal to positive square root of 3 and negative square root of 3. Okay. All right. Let's look at example 4. So here we've got x squared plus 36 is equal to 0. All right, now we can still use the square root method to solve this one, and the reason is because we're missing that middle term. But again, I need to isolate my x squared term. So that's going to involve moving this 36 to the other side. When I do that, guys, I'm going to have to subtract it. And so this will leave me with x squared is equal to negative 36. And then to convert my x squared into just x, we take the square root of both sides again. Or taking the square root of the negative 36. So we get x is equal to, and remember, you get both a positive and a negative root. Now, before I finalize this, I need to come over here to the side, and I need to simplify that radical. Okay, similar to how we did down here, how we did this one, using an I. So I factor it. I factor the square root of 36 times the square root of negative 1. The square root of 36 is just 6. The square root of negative 1 is, by definition, I. Okay? And so my two solutions for this equation are purely imaginary numbers. Or in other words, there are these other types of numbers that we don't talk about a whole lot. But they are used in math and engineering a lot. Okay? So anyway, I could list my solutions as positive 6i and negative 6i. Okay. Well, there's your couple examples in which you're missing the middle term, and your quadratic equation can be solved by using the square root method. You just have to remember how to simplify these radicals. Okay, and you're going to get, you may get some, this is an irrational number, and these are purely imaginary numbers, so you're going to get some numbers that you may not be very familiar with.
Hopefully my husband will be back.
Alright, now, I think I'll stop this video for now, because I want part 3 to be exclusively about using the third method, which will work for solving any quadratic equation, and that's using this quadratic formula. So it's a literal formula such that if we plug the values for A, B, and C into the formula and evaluate all this, it will spit out the solutions. Okay? So we'll look at that in part 3. So this is a short part 2 video for you.